everybody. It's Tyler here with Behind the Bottom at the Texas Cup. We're checking with team number 9511, Low Voltage, one of the favorite teams here. I can't wait to talk more about what's going on with this robot. By the way, joining us today, we have Rohit, Anirudh, Kyle, and Hari Shankar. And this robot's really cool. And of course, aesthetically, lots of 3D printing going on with this robot. We're going to be going through the entire ring journey. Wobble Goal mechanism, odometry, some defensive mechanisms added on here, all here coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in first to join their team as interns or for a great career. Come join a company that will actively support you being in first at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Rohit, starting off on this robot here, we're going to start with the intake of the bot. So tell me a little bit more about it and maybe some of the modifications you went through throughout the season as well with it.
All right, so the intake starts right here at this set of compliant wheels. It goes underneath here and then over this hidden set of compliant wheels at the back, which guides it up the ramp. So overall, we use like 4 sets of compliant wheels, and while the intake is rolling, this hinge box will be down, so the rings can easily slide in. We've actually gone over multiple variations using zip ties, surgical tubing, and all of that. We finally ended up going with compliant wheels to get a good grip on the ring, and so far it's working pretty well.
Can we feed a couple rings through just so we can see that process?
Yeah, sure.
And then, yeah, you mentioned, lots of compliant wheels on this robot, obviously, as it comes through. Have you guys had any issues with, like, if you're trying to, if 2 rings come together or anything like that and trying to pick that up, or has it all been kind of smooth for you the whole way?
It's been kind of smooth. We usually don't do 2 rings at once because obviously our thing isn't big enough, but usually it doesn't really jam, and if it does, we always have an easy time outtaking it and just re-intaking it.
And then lastly, I want to just focus on those little green pieces right here. It looks like this has been probably modified a little bit as it comes through. Can you just talk about how that's guiding that in, that sort of thing?
Yeah, that's a wedge. So right now with the compliant wheels, one of the drawbacks is that we don't have a lot of guidance with the rings. Usually they're just going straight forward,
sure,
as opposed to like zip ties or surgical tubing, which have a lot more leeway. So with this green wedge right here that we added, we kind of want to force the ring like more forcefully, I guess,
Makes
into
sense.
the holder.
So we'll kind of transition to that. So Anirudh, we're going to talk about, of course, lots of 3D printing going on here, right? So talk to me more about some of the design of that. Then we'll see a couple of rings shoot out, maybe a little bit more about what motors you're using, and maybe some of the compression here, that sort of thing.
Yeah, so we can start with the ring holder box. So as we can see here, the rings go through the intake, and can we put this down, the hinge, please? So it's normally in this position, and once the rings get here, it's in this downward position. Now, after that, can you please, it'll go upwards, and it's not going to go fully upwards because in the previous scrimmages, we saw that we need some type of safety mechanism. And this is a really good safety mechanism because it doesn't just instantly go into the shooter, and it doesn't like shoot people if we accidentally click
sure,
the button. So as you can see here, we use a Rev Ultraplanetary 1-to-1 motor to get this really high velocity. This velocity allows us to basically able to shoot high goals, and we also have the mid goal setting, which allows us to do power shots and mid goal as well.
Yeah, because especially now that you're playing in person,
Yeah.
right? We're seeing a lot more of that strategy for in-person matches where you have one robot going after the mid goal on the other side, right?
Yes. So now we can see how and it gets pushed by this little 3D printed piece here. If
Sure.
you can see it right here.
Just got a servo kicking that onto there.
just a
Sure.
simple servo. And this is a rev servo, but we use a 25 kilogram servo because there's a little bit of weight added here, and we need the extra force to actually push up all 3 rings.
I've been seeing more teams actually utilizing that and a little bit heavier to that for that same reason. So it's interesting to see on yours. Can we see a couple of rings actually shoot out? Let's take a look at that.
I think if some can block the Yeah, so as you can see, the rings are getting coursed through and it makes contact with the flywheel. But because of the guide here, it'll actually get compressed, meaning that the rings will actually get go in a left direction. If we can see the ring being shot here, yeah, it gets compressed and it goes in this left direction. But this also allows us to basically predict where the ring can go. And this is all 3D printed. So we went through multiple iterations. This holder box actually used to be 2 separate pieces.
Okay.
Because the original 3D printer was not big enough. Then over time we got a better 3D printer, and we see here that it's actually just one piece.
Yeah,
and
a little bit of gaff tape special on here too.
Yeah, because the problem was that apparently in the scrimmage that we went to, the ring holder box was blue, right?
Sure.
But they said don't have blue or red 3D printed parts.
Oh.
We didn't have the time to
Fair.
reprint this
Okay,
entire
yeah.
thing.
Yeah.
So we just said, let's put white gaffer tape on it. We also tried to avoid any new 3D prints, so we used black instead. And if we can stop them, we can see here, this entire 3D print plate is held by 3 screws. They're all and it's connected by an axle, and there's a bearing that helps it stabilize.
Sure.
So that's basically what we have for our shooter. It's pretty simple, but it really helps us control.
Though,
yeah,
right?
it's really effective, and it helps us like control our quality and like efficiency.
Makes a lot of sense. So let's keep going on this robot. Then Kyle's going to take over next and talk about your Wobble Goal mechanism and what you have there. More 3D printing going on with that. Something I really love to hear about is how did you figure out like how much area of air you could potentially have, right? Because some teams, they just have a little bit. Some teams have a very wide grip.
So
looks like you're pretty wide on here.
Initially, one of our main goals was to have a pretty large range that we can get this Wobble Goal to go into. So in the past, we've had this is what we took to regionals. It was just one 3D printed piece that was actually holding in the Wobble Goal against an extrusion. But then we decided to go with 2 3D printed pieces. That way we could fit it more perfectly. As you can see here, there's about a perfect circle, and it's held in from the top by just the cap of the Wobble Goal. We've definitely evolved this design over time, and this Wobble Goal design is actually inspired by our sister team that we founded this year.
Sure. Who's your sister team?
Their team 18459 Husky Robotics.
Sure.
They're brand new. We just started them.
Very cool on that. All right, well, let's wrap up on this Raw Hirschenger. We're going to be talking about odometry, some of the other features from programming that go in this spot. So tell us a little bit more about what's going on.
Got it. So for really for the whole match, we use a tool called the Roadrunner, which helps navigate the robot around the field really easily. So essentially what it is it's a path planning tool that allows you to program your robot around the field using coordinates. So you can specify the type of movement along with the X coordinate, the Y coordinate, and the heading. So that really helps because it completely eliminates the need to have to set time-based motor powers.
Yeah, and it gets rid of a lot of your drift and odometry too that you experience, right? So.
Yeah. So actually, if we flip over our robot right now, we can see our odometry pods here, here, and here. And that has really helped improve our autonomous consistency and our scores. So especially with in-person competitions, there are so many variables that can affect it, unknown variables that you cannot account for. So with odometry, we eliminate a lot of those and have a really high scoring autonomous.
Well, last thing to wrap up on this, speaking about coming to in-person competitions, I know you guys have added a little bit more for some defense and that sort of thing. Talk a little about the structural changes on that.
Absolutely. So actually, when preparing for the Texas Cup, we went to a couple of scrimmages. And what we learned, before that we were all doing remote competitions. What we learned there is that when robots knock into you, there's a very high chance of breaking your bot or even not being able to score points. So after those scrimmages, we decided that we wanted to have a more boxed robot so that it's firm. And that's exactly what we've done here with the plexiglass plates on the sides. And what that does is it protects all of our robots and makes it more structurally sound, as well as being aesthetically pleasing.
Well, that makes a lot of sense. Well, once again, 95-11, low voltage coming out of Carrollton. You guys have already had a great season so far. Looking for more here at the Texas Cup, so good luck the rest of the way here. And of course, any other competitions you might end up seeing you at too. Thanks a lot for taking the time.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.